all the things at once is a bit of a pain. Okay, so today I'm going to be talking a bit about Let's Encrypt, mainly a small bit on what it is and a bit about how I'm using it myself, and about a couple of the options that you actually have for Let's Encrypt itself. So I'm Tom, also known as TB Sliver. I work at Shadowcat Systems as a developer, but also as a sysadmin, DevOps, project management, general minion. I'm also a member of my local hackspace, and I'm one of the board members of that, and also one of the poor buggers that volunteers quite regularly for conferences and do a lot of stuff on the video stuff. You may have noticed me running around a lot today. In this talk, as I said, we'll be going over Let's Encrypt, a brief introduction of what it is and how it works, what sort of tools are available for it, what are the benefits and drawbacks to each, and then go over a few sets of scripts I created which will allow you to set this up, and why I bothered in the first place. So, what is Let's Encrypt? The short version, it's a certificate authority for SSL certificates. But the difference between them and the other authorities is that they provide their certificates for free. Yes, free. How did they do that? Well, by automating it as much as possible, and also getting a lot of sponsors.
Was the NSA on that one?
I couldn't tell, they just took the feed out. I didn't notice it, but that also may have changed because that was off the Let's Encrypt website at the time that I pulled this for this slide. So there may be more, there may be less. They may do a random presentation on the front, and I've only managed to grab a third of them. But there's a small line from large names down to Gandhi. Actually, they do SSL certificates themselves, don't they? So yes, they do. Cool. So you know that's what they're getting theirs from. No. So this is actually allowed for a large surge in SSL HTTPS secure sites, making transactions safer. And a lot of browsers have actually started putting visual warnings on. So if you have a non-SSL certificate, no SSL certificate, and a password box, it will actually tell you in Chrome itself that this site is not secure. And as of, I think, something like last week, the most recent version of Firefox also has a similar thing that says, this is not secure, please don't try and put your password in here. So there's a big push from the major browser manufacturers to actually do this. And I think some of the other browser manufacturers that I can't think of the top of my head, apart from Microsoft for some odd reason, are also doing this. So let's take a very quick look at what an SSL certificate is for. I'm assuming most of you actually know what they're for. Anyone raise their hand if they actually have never heard of them before and this is the first time they've ever heard? Okay, this might go, this is going to be quick anyway. I thought this might be the case. So it's used to identify a host and encrypt the traffic to and from said host. Using a certificate and key provided by the host helps prevent man-in-the-middle attacks and helps people stop impersonating your servers by using like DNS manipulation and stuff, which is, let's not look into that. Obviously, this is not as secure as you'd think because anyone can generate one. Anyone can generate an SSL certificate for a particular FQDN. The difference here is it's obviously signed by a CA, which has been trusted by the browser manufacturers, and so you know your browser can actually check the chain of trust back to someone they trust, and therefore you know it's the right server. So with Let's Encrypt, that's going to be annoying. Never mind. To make this system actually free, they went basically the only way they possibly could. From requesting your certificate through the system to checking you're eligible for it, to actually receiving your certificate and having it on your machine, takes less than 10 seconds, assuming you've got all the config right and everything's in the right order. Obviously, the old way was you had to prove that you were on the host name, which with the original system, create a certificate signing request with all the details you require for that. This you then sent to the CA with a large bundle of money, and then, after payment, obviously, sent an email to an email address of the FQDN that you registered. Normally, I think it's postmaster at insert FQDN here. Doesn't take that long to come through, but it still costs. In fact, I actually checked this. £30 is the minimum on 123 Reg for an SSL certificate when I was writing this. And if you want a star certificate, please ask your managers for a lot more money. Especially if you've got a very nice domain name. I don't want to think how much Facebook pay for their domain SSL certificates. Obviously, if you want one to just cover one, 30 quid, star domains allow you to cover more, so on and so forth. I've missed a few, there we go. And you also need email hosting. I missed that on the notes. Because obviously you need to receive an email on that, and if you haven't set up email hosting, then you know how much of a, if you have set it up, you know how much of a pain that can be. So Let's Encrypt allows you to do it one of two ways. Either using a well-known Acme challenge with a file on your server at a particular endpoint, or using the DNS challenge, which allows you to put a text record in your DNS server. For this, I will only be going over the Acme challenge version because DNS is something I'm still yelling at. And also, I don't want to run my own DNS servers because I'd like that to be someone else's problem. So, an Acme client on your server makes a request to the Let's Encrypt system. For example, we're using example.com. The Let's Encrypt server then comes back and says, put this text string at this endpoint, and also sign this nonce key with your private key, so it can prove you. You've also done, there is a key exchange earlier on. Obviously, then the client puts that, oh God, here we go. Client puts that there. The Let's Encrypt checks that against the host name using DNS, and then you send back the encrypted bit with your public key. If all that works, then the client sends a CSR, which is signed by, oh God, I've forgotten which one it is. It's signed by the Let's Encrypt side, encrypted with your key, which Let's Encrypt then decrypts it with, and then you eventually get your SSL certificate. I think is that the next slide? No. Biggest thing about this, it's designed to happen regularly. So obviously all this is run reasonably. I run mine every day. And the certificates you are submitted with last for 90 days. So you have to refresh at least every 90 days. And you will actually get an email when you get down to, I think it's 9 days left, and it will email you once a day until you refresh. And after if you've refreshed, it stops. If you haven't refreshed and you get to the end of that, it says, well, your problem now. So there are quite a few clients actually available for this, written in a variety of different languages for multiple platforms. So there's Certbot, which is the official one, Lego, which is one written in Go, Let's Encrypt Go, Acme Sharp, written in PowerShell. And these range from systems which do everything, including spinning up a web server for you. For example, if you're creating it for a mail domain, then we may not have Apache on there or a web server or something, so you can actually do that. To those which give you basically all the bits you need to do this, but don't do it for you, as it were. They don't automate the whole process. They both have their advantages and disadvantages, and I won't be going all of them, but obviously there's a lot more available. I think there's about 30 or 40 different ones available, just actual clients on their website. So let's quickly go over a couple of them. The first one I'm going to go over is Certbot, which is the recommended client on their website. And it can do everything from a fully automated setup to what they term expert mode, which is where you can do every single separate step yourself and one time at a go. It's very simple to set up. It's written in Python. It's very simple to set up. In fact, I told you to do the whole thing in one go. You add you need Jessie backports for this. For example, if you're running this on a Jessie build, and then you do apt-get update, apt-get install, Python Certbot, Apache, if you're using the Apache one, with the target of Jessie backports, and that will install everything of that. This is great for a lot of things and brilliant for when you just want it done, but it does have the ability to reach into a lot of things, such as your Nginx or Apache config. It does actually mangle those. So it will reach in and put its own virtual host into an Apache or its own server block into an Nginx, and you need to run it under sudo as root. Not something you probably want to play with. Have I missed a thing? Oh, and then you just run certbot Apache and it does it. I missed the run line. Lego is Let's Encrypt Go. It compiles to a single file, Acme client, which doesn't require sudo, but does require either ports 80 or 443 to be forwarded to it when it's running, or read-write on a file in the web root. Obviously, I found that better, but as it doesn't touch as many things, you give it the things from your web server, and although it's a work in progress. Well, you can't read this. This is a work in progress. Please do not run this on production. I know a few people who are running this on production. Yeah, I think they may actually maintain it, but never mind. Obviously, it's a single binary setup, quite useful to compile and go, and just copy it over because that's the way Go actually works. The one thing I didn't like about that was that I had to actually create a full Go build environment to actually build it to then install it, and it's sort of, I just sobbed that. There's also a lot of other ones. So you got ones that are written in Bash, raw actual plugins for Nginx and Apache. Also a ton of language libraries so you can write your own. So these range from, well, obviously Perl, Python, Go. There's a Ruby. Insert language here, there probably isn't one in Brainfuck. But that one doesn't really do much web stuff anyway. So why did I build another script? Well, it's not that they weren't good enough. Okay, so Certbot I didn't like because it required sudo to run. And the dependency tree for it was huge. Obviously, it's a full Python module, so it requires half of the Python tree to install to do that. Lego was a good competitor, but I didn't want to run large dependency tree. I didn't want to create my own build environment so I could actually build the thing for it, because I don't know enough about Go, and the first thing I do most of the time is break something. And so what I did was what any Perl developer does. I reached into CPAN and pulled out crypteli, which, if you go to p3rl.org/crypt::le, that's actually the meta CPAN page and is the full module for that. This is designed to talk the Acme protocol, and the actual author uses it for a website called Zero SSL, which does all the Acme stuff for you-ish. But you have to put stuff you put your private keys encrypted into the web browser and then press submit. So you're submitting your keys and bits and pieces on their web browser, and let's not go there. But what I ended up building, it was a quick set of scripts which you can run as an unprivileged user, set up however you deem necessary. So you can set up your user access rights for this user. Mine has its own group, its own home directory. It has no way to look outside of the area. And it uses a simple JSON-based config file, and actually has self-contained dependencies. So all the dependencies run and are installed under that user in the directory that you install it in, that you actually git clone or extract it with. And the other nice thing about this, my module, is it supports multiple domains. So if you are running something with SNI, you can actually run multiple host names, multiple domains on this server without on the same IP address. Turns out that Let's Encrypt, if you want multiple host names with separate SSL certificates, you actually have a limit of 5. So you have the root one, so tbsliver.me, plus up to 5 other five other SSL certificates. So I could have, I've got paste and a few other ones that I've used for dev and a few others I've used. But you can only ever get 5 certificates, sorry, 6. I can't count my own hands. 6 certificates send out to any one domain. But
Do you mean IP address?
no, because it checks over DNS. So it does the host name. It does the host name and check that you've put it in the right place over DNS for that host name.
So if I'm running on one server, multiple vhosts under different domains, then I can have 20.
Yes, quite happily. IP address is not locked, although they do have load limits so that you don't just hammer their system every thing. I think their limit is like 20 or 30 in an hour. But you can just stagger that and do sensible things like do someone one day, someone another, someone another. Nice and simple on that. So that load is just so they don't end up completely hammering their system. Obviously, if you've got it, but they have a limit of 5 + 1 for the actual separate SSL certificates. You can actually run. I could actually run www. No www. And paste all off the same SSL certificate, and it wouldn't mind. And that gets partly gets rid of the SNI issue, which is probably what I should have done in the first place. Was that a question? Or? So let's quickly go over the setup of it. So first, set up a user. I will let you figure out your favorite way of doing that, whether you're doing, I don't think this runs on Windows, so never mind that, but you'll have your own preferred way, and I can never remember all the arguments correctly for user add. As long as it can run the script, you don't care. Then you just need to clone the script or pull out the tarball that they do for every GitHub automatically does for each one. And you will also need the SSL dev headers. That's just so it will actually compile the OpenSSL certificate buildings module that this runs on. Obviously, this runs on Perl, so you have that already unless you have that with a modern enough version, unless you're running something like Red Hat from the 1990s. Yeah. yeah, obviously. It'll just about backport. Patch is welcome. Simple apt-get for that. We'll get the OpenSSL bits. So the next bit is to run the setup script. This actually, there is a line there. Come here. There we go. So after you've cloned it, change into the directory, and then run the setup script. This will fetch all the dependencies from CPAN that it needs and install them in a folder called local in that folder. Nothing is touched outside of this folder when you're doing it. It can take a few minutes, depending on how powerful your server is, what your rest of your load is on the server. But after that, it should finish with no errors. If it finishes with an error yelling about SSL, then it's because you forgot the dev headers. I've done that multiple times when I'm testing this thing, so don't count yourself lucky if you hit that. After that, you can set up a config file. So I've got an example config file there. Copy it across, and then open in your editor of choice. And then here is the simple example that's actually included with it, which has got 2 sets of certificates it'll fetch. It will fetch a main one, which will have an SSL certificate that's valid for example.com, www.example.com, www2.example.com, and then a dev one, which is dev.dot and dev2.dot for it, and also an email address that's set that if you set that to, you can set that to any email address. It doesn't have to be at the host that you're running it at. Mine goes to my Gmail address, and that's the one that you will get when you're where you will get the email that these certificates are about to expire.
Sorry, and those are the each one of those domains. Example, www2 dev and dev2. Those each takes up a certificate of that 6 limit.
This takes up 2. So that's one certificate with multiple host names under it, and that's another certificate with multiple host names under it. But they're both for example.com.
Okay.
So you could have up to 5, 6, not 100% sure. Read their documentation for that bit. But I could have 5 that were for example.com. And so, for example, if I needed mail.example.com, I could have that as a fully separate one that I can ship off to another server using whatever means you feel necessary. Note that this is raw JSON, so you've got a standard value key, value object for that, and then each of these is a key for what you want to call this particular key. Wow, that's a lot of keys. And then the value is an array of all the host names. The first one is the primary host name for this key. If you understand what that means, good, because I'm not 100% sure either. Yeah.
Subject name, the other ones are the stands of subject alternative names.
Probably. I'm not 100% sure how it works under the hood, but it's been serving me fine for a while, so I'm leaving it as that. Obviously, the next step is to set up a challenge route. So the way that, as it was in the diagrams at the beginning, what it does is it looks in a particular place. So this uses the webder-based endpoint. So you make a folder called challenge route, because in the directory you deployed it in. This is a fixed name, but patch is welcome if you want to actually change this. It makes no major difference. And then you need to change it to readable by whoever the web server is running as. So probably make it readable by group or data or whatever you're running it as, Nginx thing. And then it has to be writable by this user, and that's it. So chown were data, chmod 640. I think that's the correct one for read only, read, write, read. And that's just so no one else can interfere in the middle of it and get your nonce and do anything crazy with that. The final bit is the configuration to your web server. Here is an example for Apache. And actually, on the code base, it actually has an example for Nginx as well. You just put the path to the challenge route you created and alias that to .wellknown/Acme challenge. Which I'm fairly sure not many of you have got as a URL on your website already. And if you have, what are you doing? And then just that alias to there. If you want to be more secure than that, fail free. I'm not 100% sure on all those, but that at least gives me a 404 error when I try to browse the folder, and will at least let it just read the file in there that's designed. The actual string and file name is fairly long. I think it's like 20 or 30 characters, so it's fairly difficult to guess random characters, and it's only there for the process of the actual key sign. After you've got that set up, you can actually just run the script. So you have two options, /getSSL, or run it with the live option. And this is when it talks to the Let's Encrypt servers and pulls all the bits back. If you'd run it without it, it's talking to their development servers, which means you will not get a valid SSL certificate, but means you can check that you've got all of your bits, everything in the right order and like the JSON files correct, and you can actually then look at the SSL certificate to make sure it's got all the right service names without actually wasting a live certificate on it. If you run it with just live as plain text at the end, it will go to the correct live one and put that in the folder called certs. So if you, from the example config earlier, you saw it was main with all the example.com bits. The actual certificate is in certs main, and then it's the various parts of the certificate as it sends you, including the CSR in there. And for the dev one, it will be certs dev. The development ones are in certs-dev. And then you just need to tell either move the certificates to where you want them to, or just tell your web browser to look, your web server to look there for the actual certificates, because this is a completely separate user, no one else can read this anyway, and lock them down as required. So obviously, this is a fairly hands-off of your system setup. It literally has two dependencies, as it were, the SSL dev key and Perl, which is on every major distribution because it's required by a load of core systems. So if you want to move the certificates you want anywhere else after getting them, or as well as restarting, reloading your web server as you need, to pick up any new certificates, that's up to you. I have my Let's Encrypt script cron job running at something like 27 minutes past 2 in the morning, and then at 3:15 my server I just have my Apache server reload and it's done. And so that just happens every day. Probably a good idea anyway, because I'm running WordPress and that has its own set of issues. But after all that, you will have your own certificates set up. And then, oops, not too far. Let me go back. And you can redirect all your traffic over the HTTPS endpoint. You can also move the config that we put in earlier in Apache into the 443 endpoint, because it will follow the redirects that if you put in, say, a 401 redirect to HTTPS for your server, it will actually support that. That got me confused because I did the redirect and forgot to take the alias out of the list, but never mind. So then, when you next do an SSL certificate signing, it will be doing this fully encrypted as well over the wire when it reads everything like that. Doesn't matter quite as much, but still, it's a nice addition. So that's a whirlwind tour of Let's Encrypt, and the reasonably simple solution that I came up with. It's what I'm using on my personal web server, and the dependencies are, as I say, all you need is a Perl from this century. Anything Nix or BSD based would be covered by this. It may work on Windows. Don't guarantee anything, but the modules I've used are basically fairly Windows compatible. Patch is welcome. And also, if you find something that doesn't work, feel free to send me a bug request, or if you want to help improve the documentation, because it's not too bad, then again, pull requests welcome. I'm using it in production. It's all right, forgot these one too, but PL's welcome. Any questions? I'm a bit early.
All of these are going to be included in the what I can download from the FLOSSUK website.
Yes, I'll provide a copy of the slides on the FLOSSUK website, and they'll also be up on the recording, assuming I didn't completely balls up my own recording. That's on at least, and this is on, so that's a good step. So you'll be able to watch it through again, and I'll export the slides somewhere useful, and all my notes from it. Any other questions?
Have you tried using the piece of software called Dehydrated? And what that will do all the boring challenge response thing for you, and then it will call the script that you specify with the command line arguments of the challenge and the response. Your script then goes and does whatever's necessary, uploading DNS records or whatever.
Yeah.
And then when it returns, assuming it returns 0, Dehydrated will then go back to Let's Encrypt. So you don't have to do all the boring boilerplate stuff. Yeah. You just do the little bit that shoves it up to your DNS or website.
Right. So CryptLE does all the key exchange and all that stuff. So that my script is actually with documentation about 40 lines long. It actually just shells out to in a Perl script because that was the easiest way to do it. But that's dependency that's still installed in there. So it's actually a extra script wrapper over le.pl, which is a binary provided with the CryptLE setup, but the arguments list is longer than my arm, and it provides a lot of flexibility. This is just you literally run curl URL for the git, tar.xvzf, tarball, cd in /setup /get SSL live, assuming you've already got the config set up. And that is it. That's 4 lines. And
CryptLE basically does what Dehydrated does, what that sounds like.
yes. Yeah, I'm assuming Dehydrated is do you know which language that's in?
I think it's written in Python.
Yeah, so it'll be a
It'll
be a Python module around the probably the library from Certbot, they use underlying for theirs. The actual protocol this is called is not Let's Encrypt. It's called Acme Challenge, and it's actually got a fairly formal specification. I think it's also still fairly stable now. I don't know if it's gone 1.0, but everyone's using it these days, and they have. I actually don't know how many websites they've got currently running under SSL. They've actually sent out, but it's definitely in the millions, probably several hundred million now, or something like that, of actual certificates they've sent out. Yeah, and if you want to give a patch that actually then runs a script for you, the problem is obviously privilege escalation, because that cron job runs as the user that you set it up as, which is why I find it's a lot more secure, because that user's got no privileges at all.
Sounds like you've pretty done much of what I have, except I've written a book script for dehydrated and you've written a script effectively for crypto.
Yeah. Any other questions?
One other use of certificates that I've been vaguely thinking I ought to get round to do for a long, long time, would probably interest Nigel here, is for sending email, which can be encrypted by TLS, but then it's open to man-in-the-middle attacks. Will the Let's Encrypt certificates, can they be used for that as well?
I would assume so. Do you know?
I use Let's Encrypt certificates with PostFix, and it just provided both sides of the email exchange support TLS.
Yeah.
And obviously you can make it mandatory if you want, but then you won't get much email from people.
No,
so,
no.
But yes, and the UKUG server, for example, has Let's Encrypt, and if you send an email to a UKUG.org address and your server supports TLS, the UKUG server will accept it over TLS, and so it'll be end-to-end encryption, even if the email's not encrypted.
Yeah.
Right.
So yes, and in postfix it's pretty trivial. You basically say, here's the SSL certificate, and if you're sensible, you also say, make sure you disable SSL v3 and stuff.
Yeah.
It's disabled by default, I think. But there's a bunch of options. If you want the exact options, then I have to share them.
Well, I'll use XM anyway. So.
Well, yeah,
Yes. No, actually, because I generate my own ones, it was just making sure whether the Let's Encrypt one will work with email as well.
Yeah, I've seen the weirdest one I've seen is Cisco AnyConnect. Someone's deployed Let's Encrypt SSL certificates on a Cisco AnyConnect. You've just gone to sleep, haven't you? Wake up. And that's probably the weirdest one I've seen, because obviously you can't log into the Cisco router to actually let's install this script or anything to actually get that, because one thing you may not have is a host name attached to it, or at least one of the ones that one of our clients has has no host name attached to it, because I don't know. You had a question?
It was a comment. When I heard your question first, I thought you meant signing email messages.
No.
And Let's Encrypt
I'm talking about
won't let you do that. You have to go to
OpenGPG or something like that.
Another certificate authority if you want some personal signed certificates and so forth.
Yeah.
So it's just the transport there.
Yeah, which is still a good start. I don't think they gather data on how many people actually use this for a TLS encryption over the wire for email, but probably they may be able to do a grep over their logs for mail dot. That'd probably be a fairly good indication of how many people are doing it. Any other questions?
Has anyone hit the limit in this room?
I have.
Especially if you're not careful, they have a staging server. So if you're writing some software like this, for example, you test against a staging server which has much higher rating. If you accidentally don't do that, you get kicked out.
Yeah.
There's also limits on things like if you want to create a single certificate with loads of subject alt names, I think the limit's about 100.
Yeah. So
and you can't have wildcard certificates. And you can't have extended validation certificates, so you can't You can't prove that you are who you say you are. You can just prove that you have.
You own the domain.
Well, you don't need to prove that you own the domain. You can prove
Control
that
it.
you have the ability to upload a TXT record to the domain,
Or in my case-
poison the cache between Let's Encrypt and
Yeah. There is, I ran into one recently actually. This is how I actually know about the 5 limit, because I tried to get an SSL certificate for a big V instance. Someone's already got them all. You cannot get bigv.io, even if you're on one of their reverse proxies for it.
You also have a limit per domain.
Hmm?
You also have the limit per domain, not only per IP address.
Yeah. Any other questions? No? Well, thank you for watching. There's another one. Find me on GitHub, Twitter, IRC, and also on the web at my website, tvsliver.me.